Okay, hi everyone, and welcome to the day one of our USC R Bootcamp. And thank you everybody for joining us today. So today we have roughly 50 minutes to start exploring what is R, and also dive into some of the interesting data visualization examples in R. So my name is Natalia. I am a fourth year PhD student here at USC in the Biostatistics department, and I use R every day for my research. For example, for the next month, my plan is to wrap up all of my functions that I've written for my method into an R package. And I just finished my internship with the whole data science team that use R primary. And this is partially because R has such a powerful data visualization tools, right? So, for example, to generate a hypothesis or to pick an appropriate model for our data, first we have to explore our data and visualize it from different angles. That's why R is a nice language to use for it. And today, if you guys have any questions for our presentation or when I'll be doing our hands-on exercises in R, please reach out in the chat, and then George and myself will help you guys. And George is one of the most talented R developers that I know, so you guys are in the good hands. So our plan for today is to explore what is R, what is RStudio, what are the differences between those two concepts, to find out how to get help in R, and it is very important. There are so many functions, so many data sets that can be stored in R, and you can use a help command to get all this useful information without even starting to Google all of these functions. And then finally, kind of the large portion of today's presentation will be about a live example with Ggplot2 on the diamonds data. So what is R? R is an open source programming language for statistical computing and graphics. And open source means that there is a large community supporting the development of our language. There are so many useful links on the web that are available, tutorials, examples. And I think there are around 13,000 packages available to install in R. And one of them should be soon to be mine package. And there are a lot of packages that George developed. And then RStudio is what is called an IDE for R, so integrated development environment. For example, if you guys are familiar with Python language, then Python will be our programming language, and PyCharm would be one of the available IDEs for Python. And for R, it is RStudio. And George found this very nice tweet example of how to explain what is the differences between R and RStudio. So what is the differences between the actual programming language and the IDE for it? So let's look at this analogy, and let's imagine that R is a car engine. It's like a car's engine, so it actually moves the wheel, it drives the car, so it does all the work. Like R does all the calculations at the back end. And then RStudio is like a car's dashboard. It has a steering wheel, it has all the controls, and we interact with a car by using this driving wheel and the controls. It's the same how we would interact with R by using RStudio. So it is a nice analogy. So there is a engine and there is the control of this engine. We are the IDE if the engine is your language. If you guys already installed R, then you can use R directly via the terminal. So this is would be the mock terminal. And let me show you an example. So I'm opening my terminal. To start running R, I'll just put capital R, press return, and I'm directly now in the R console. So I can type any equation here, write a function. However, it is a console, it is not an editor. So I can, for example, use it as a calculator to find out what's the price of my iPhone with taxes. So let's say it's something around $700, multiply by, let's say it would be 9%. So we'll get the price. And to exit R, we would use Command Q with a parenthesis and hit enter. And depending on whether you want to save your workspace or not, we exit in the terminal. So this is like quick access to your R language. It could be done via terminal. Then there is RStudio. So let me show you guys how it looks like, what are the most important kind of settings of RStudio and how to use it. So this is my RStudio. It has 4 important sections. So we have the editor section, then we have the console section where we actually run all the code. And in the editor section, we usually edit the code or write our scripts. Then there is environment that will show off all our variables. And this section where we have files, we will see the plots if we want to display any of those, available packages, and also the help. So in the editor, I can write, for example, I can create 2 variables. Let's say it would be A and B, and assign them 2 numeric values, 100 and 200. So if I put my cursor here and run command return, then I'll see that this command appears in the console, and then we see that this variable now appears in the global environment. So we have the variable A with the value 100. It is a numeric variable. And then I can also highlight the whole section of the code and press run here, or again, highlight the section and use command return. This, I'm using Mac, so this is for the Mac users. And all the commands will be displayed in the console. And also, probably for you guys, console is usually here or below the editor, and you can set your RStudio in any way you want. Your editor could be on the left, on the right, below the console. It is all can be set here in the view. So I go to the panes, and then there it says that console on the left or console on the right. If I put console on the left, this is probably the same setting you guys have. So the console is down below. I just like my editor to be expanded as much as I can. So I usually put console on the right. And then if we go to view and then panes and then pane layout, this is where you can set it up however you want. For example, you can put source code or your editor right in the kind of lower part of your screen and so on. So you just can choose any of those options. What is a fun part to set up your RStudio is to go to Appearance now. And here, you can choose a very nice editor theme. For example, there is nice kind of gray scheme theme that's applied. So it kind of looks nice. So a lot of my friends, they prefer this black screen. And I'm more for a classic setup. So I use a white. But you can change it if you want. So it would be your basic RStudio setup. Your code and your scripts go to editor, and then you run it in the console. And you can control all your variables. You'll see whether they got assigned the right value in the environment. Okay, let's go next. So for today, we'll have this hands-on exercise together, how to create a nice ggplot display. And here would be a couple of useful links for you guys. So the code for the section with the ggplot commands can be downloaded here, and George will send you the link in the chat, or you can guys always email us if you want to get the links. And the whole Markdown presentation is available at this link. So you guys can see that there is a very nice tool called R Markdown, where you can create very nice reports or nice presentations that can be displayed in HTML or Word or PDF. And you'll find out more about the R Markdown in day 3. So let's start our setup. So we want to attach the Ggplot2 package and our diamonds data. So for those of you guys who haven't installed Ggplot2 package yet, I'll show you guys in a second how to install the package. But let's say we have this package. So we will attach this package by using the function library. And then we will attach a data set that we're interested in. So we're exploring this diamonds data set. We'll use the function data. And if these two functions are new to you guys, there is always a help function that can explain what is this function about, what are the arguments of this function, and what are a couple of examples of how to use this function. There are multiple ways we can get help. So either type help in name of the function, or this is, I think, the easiest way, just to put a question mark and a function. You can even omit quotation marks here. So in R, it will be very simple. So I'm opening up a script. So you would guys need to run this command to install a package. So we'll just type install.packages ggplot. You'll run it into your console, I'm not doing it since I have this package already. So I'll start by attaching the library. So I'll run library ggplot and then attaching the data. And let's see what is library function actually doing. So I'll put a question mark in library. And we see that there is a help window. Can enlarge it, and then all the information about this function will be in this window. So there is a high-level description of what this function does, and then how to use this function, then all the arguments that go into this function optionally, and more details about how to use this function. What is it about? Some additional information. Then the ownership. So who wrote this package or this function, and then what is probably important also, that they have the examples of how to use this function. So if you guys are lost or just don't know what is this function is about, just quickly type question mark in the function and see how people usually use this function and what this function does. We can also type help and function data. Again, in this help window. And we see that this data function loads data sets, and there are arguments for this data set lists here, and all the description of this function and examples at the end of the information. And also we can use just directly this field to write any function we want. And again, we'll get this help window. So now, try it for yourself, guys. So let's say we're interested in what are the arguments the data function accepts. So how will we find out? And then this is a new function, str. So what does this function does? And we're going to use it later. So it's a good time to actually explore what is this function about. And since it's a recording, I'll just show you right away how to do it. So we'll just type help data again and look at the arguments list. So that's how we can get a list of all the arguments. So for example, there is a package argument where you can specify the package where you want your data set to be loaded from. So for example, for our case, diamonds data is loaded from the Ggplot2 package. But since there is no other package that have this data set, we don't need to specify a package. Only if there is, for example, two packages with the same data set, you have to specify. So the data function knows where to pull this data set. And then str function, it has a very useful function. Let's see what it does. It displays the structure of any R objects. So we can, for example, look at the str of the two variables that we created before, A and B. Oh, sorry, A. And by the way, R is case sensitive. And then we see that there is a numeric variable of the value of 100. Or we can try to use our data object and look at its structure. Now, for the data object, the structure function gives this nice brief summary of all of the features that is stored in this diamond data. So we see that there is the feature caret, cut, color. Caret is a numeric feature, then cut and color and clarity are the ordinal factors, which are the categorical variables with natural ordering. And this is the ordering presented here. So just a nice summary if you want to look into your data. Let's move on. So kind of continuing on the topic of looking at the data, there are two important data structures in R that usually store the data. It is either data frame, which is a base R component, or table, which is a component of this set of packages called tidyverse. And you guys will learn about tidyverse tomorrow and how to manipulate data with tidyverse packages, for example, the Gplot package. And tables and data frames are very similar structures. They both have your samples or your individuals or your patients as rows, and all the characteristics of the patients or your individuals as columns. So your features would be columns and your samples would be presented in rows. So patient 1, and then maybe it's age and gender, then patient 2, patient 3, and so on. This is how it looks like in R. So here we're looking at first 6 rows of the data set. It can be done by using the function head. I'll show you guys in a second how to use it. And then when we use this function, we just see first 6 rows. It would be like first 6 diamonds in their characteristics in our data set. So we see the first diamond, its weight, its cut, color, clarity, and the size. And the data frame version of the same data is pretty much the same. We just do not see the types of the variables. So here would be double, this would be ordinal variable, ordinal, the price would be integer variable. So it just tells us a little bit more information in case when we display it as table than as a data frame. And of course, we want to understand the size of the data set. And we can use a dim function to get the both rows and columns, or we can separately look at rows, number of rows, so it would be our sample size. So in case of diamonds, we have 50,000 diamonds as our sample, and we can use number of columns and col to understand how many features we have in our data set. So it would be 10 features. So let's see in R. I used a function head, and I put the name of our data set diamonds to get a quick display of my variables, all of my features. So I can see that there are some of the factor variables or categorical variables, some of the numerical variables in my data set. The same for the data frame. It omits the types. And then the help can be also used to pull up information about the data set, not only the function. So here, let's say we're looking at this for the first time for the diamonds data set. We don't know what's inside, what does caret mean? So we would just use question mark diamonds, pull up this help window, and then we can read about this data set. So okay, this is the purpose of this data set is to collect prices of many diamonds, and also collect these important features of the diamond, which would be the weight of the diamond, the cut, the color. Then we'll see the categories. D would be the best, and G would be the worst. So we have some understanding behind the labels of the color. And also we have the clarity. How clear is the diamond? From worst, blurry, to the best, very crystal clear diamond. So all of the information can be pulled up in R again about the data set. And we already used str, just again to look into the types of our predictors to understand our data set better. And again, to understand the dimensionality of our data set, we can use the function dim, which will tell you right away their sample size and the number of features. Or if you're only interested in sample size, you'll use number of rows. It will be only the number of diamonds in your data set, or the number of columns would be the number of features on your data set. So this is the simple and important ways to explore your data set. Look at it with head, look at the dimensions, look at the STR, and of course, read help manual about your data. Okay, so we know the data, we attach the package. Now we're ready for this very nice data visualization using Gplot package. So in the next couple of slides, we'll teach you guys how to build this plot. And let's take maybe a couple of seconds to see how multidimensional is this plot. So we are plotting the price of our diamonds by the weight of a diamond, so it's a carat. So we are looking at the scatter plots of these two variables, how price depends on the diamond weight. Then we also have the color of each point. So each point here would be a diamond. So this is a standard scalar plot of two continuous variables. Then we're also coloring each diamond, each point, by the actual color of the diamond. So there is these factors that indicate the color. D would be the best one, the most clear diamond, and G would be the kind of yellowish diamond. So we also plotting the color of our diamonds by the color in our ggplot. So we're adding third dimensionality to our ggplot, and it is interesting. For example, we can see that for the diamonds of the same weight, the yellow usually is in the bottom range of the price, and the dark purple or blue is in the high range of the price. So not only price linearly kind of linearly depend on a diamond weight, it also depends on the color of the diamond. So it is a lot of inference we're getting from just the plotting of the data, and then we're adding the fourth dimensionality to all of this relationship where we are stratifying our price and diamonds by the clarity of a diamond. So now here would be only the diamonds with the clarity I1, which is the poorest clarity. It's the most blurry diamonds. And then we'll see that there is IF would be the most clear diamonds. And it is, again, gives us a lot of conclusions. We see that the price doesn't rise as quickly for the poor quality diamonds as it happens with the clear diamonds. So you see here, for 1 carat, it is 5,000. For 1.5 carat, it is 20,000. The price doesn't rise as quickly as, for example, for the poor clarity diamonds, where it's more or less linear. So if we want to predict the price of a diamond with these features, we have to make sure that we model differently by the clarity. And these conclusions we get just by looking at this plot. So the visualization is very important. So now let's see how we can actually build this plot with a ggplot of our package. So the ggplot function starts with the ggplot function specifying the data set. So we will say data equal to diamonds. Then we have to specify the specific genomic function, geom function, not genomic function, we want to use to to plot our data, and there are many types of functions you can use. Any function you can think of, for example, a histogram, scatter plot, box plot, bar plot. Ggplot will have this function, and then so we have to specify what exactly we want to build from our data. So let's say a scatter plot that we just used. Then we have to specify how features of our data to be included in the plot. And it will depend on the exact function you want to plot. For example, for scatter plots, we usually want y-axis to specify y and x-axis, right? So because scatter plot just plots two continuous variables. Or if we want to plot a histogram, we will only consider one variable, one continuous variable. So your mapping depends on the function you will use. And then the plus sign is the specific syntax of the ggplot function, which connects all of your options that you want to specify for the ggplot. So let's see how important to specify all of these parameters for a function. So we start by typing ggplot and then inputting diamonds data. And we see that if we run this command, nothing actually gets plotted. This is because we didn't specify what type of plot we want to display. We only specified what data we will work with. So next, for example, we did specify the exact plot we want to display. GeoPoint means that we want to display a scatter plot. However, again, for the scatter plot, we have to specify what are the two continuous variables we want to plot against each other. So we have to specify y and x. Otherwise, we'll get an error message. And also, it is important to look at the error message. Most of the times, it can really help you to troubleshoot your code before Googling again. And now we did everything right. So we specified the data set. We specified which function we want to build. So it would be scatter plot. And then we specified that we want to build price against a carat weight, so the diamond weight. So it is already very telling plot, right? So we see that there is a linear correlation between price and carat, since when you increase the weight of a diamond, the price increases. So that is a very nice conclusion out of this plot. However, we can also see that when we focus on the diamonds with the same weight, the price range is still really high, right? The really large, the price range. So the carat is not enough to explain the variability in price. So that's why creativity comes in place. So what other variables we can add to this plot? And we're thinking, okay, let's add a color of the diamond. And to add a categorical variable to color each of your diamond by this categorical variable, we use this option color, and then we will put the variable. So here could be color equals to clarity, and then it will be, we will color each of our diamonds by its clarity value. Or it could be color equals to cut, and you guys can play around and see what will change with this plot when you use a different coloring categorical variable. But here I'm using color. And again, now I have more understanding of the price of a diamond, since I clearly see that for the same weight of a diamond, the diamonds that have lower price range are the ones with the more yellowish color, and the diamonds who have a higher price range, they're actually the ones with the clear color. So D, E, F, it's clear color, and other ones are the yellowish color. So again, now we better understand the price. We know it depends on the weight and also on the color. And now there is more dimensionality we can add to this plot. By using the facet wrap function, again, we're using this plus sign since we're adding on to the constructions that we built before. We say that we actually want to stratify all of our scatter plots by the clarity value. Clarity is a categorical value. So for each of the value of clarity, we'll have the different scatter plot for the diamonds of this clarity category. And again, I1 is the most blurry category of a diamond with respect to clarity, and IF would be the most clear, see-through diamonds. And again, we have more information now about the relationship of price and all our features. We see that if we want to model our price with regards to carat, so the weight for the low category or low clarity categories, we should use linear models. But then for high clarity diamonds, we probably have to think about polynomial models. So we see that the relationship are different depending on the clarity. So it's something to keep in mind when we will model this data. Again, we didn't do any statistical tests to understand this. We just looked at the plot, just at the data visualization. So it's a really powerful tool to understand your data and to select a model. So, and the last step for our plot is to make sure we labeled all of the axes and got a title for our plot. For example, if we want to use it in a report or in a paper. And so we use the plus sign again, which is really nice syntax where you add on to your plot, you just add functionality. And you use function labs to specify your title, your subtitle. Here would be your title, subtitle, your Y and X axis to explain what is that we're plotting the price against the weight of a diamond. You can put any detailed description here. And also you explain what do the colors mean. You can elaborate on the categories that D would be the best one, G is the worst one, and then this plot can go to the paper right away. So we explain everything that we're plotting on this nice picture. So now let's go and slowly repeat these steps in R so you guys can build this the Gplot by yourself. And you've seen that it's actually just a couple of lines. So again, we'll see that Gplot just gives us this gray screen. We didn't specify what type of plot we want to see. And when we specify the type of plot, it is enough to build it is not enough to build the plot since we didn't specify what variables we want to see. And here, it is my idea to plot Y as price and X axis as carat, but you can change anything here. You can use other, for example, there were sizes of a diamond, a table of a diamond. So you can use those to explore your data in the scatter plot. Then we're looking, so here, let's see that we're getting this nice scatter plot. It takes time since it's 50,000 diamonds here. So here is our scatter plot. It is very useful, even without adding any color, just to understand the relationship of your continuous variables with each other. Before even going into any modeling, you have to look at the relationships. And then we're just adding colors. And as I said, it could be any categorical variable. So I can put here, for example, cut variable and close. And then I'll see that now it is plotted and the color represents the cut of a diamond. So now we actually can see that the fair cut has the lowest price and the ideal cut has the highest price, which of course makes sense. Then going back to the color categorical variable we used to color the Gplot, we adding more dimensionality, we're adding clarity as a facet wrap. And again, it takes time since it is a large data set. And also we can zoom in on the plot, press here, just to look to see more of our plot, to see more clearly what is going on we see there is really linear relationship in this strata of carrot and price relationships, and we see that here it doesn't look like linear. It is clearly grows faster than linear, so it's some kind of a polynomial relationships, which is important to understand the relationships. Okay, and then here we're just adding the labs. So we're adding the title. We can omit subtitle, or we can add subtitle if we want. We're adding X and Y variables, labels, and the label for the color. So this label to explain what does this category mean. And we are getting the final plot with all of the explanations, the full dimensionality. So here we're plotting price against 3 variables, not 1, which is pretty nice. And we get the whole story of the relationship of these factors, of these features in the price, which is nice. And you guys have all the code, and please ask questions if anything wasn't clear. And I just wanted to give you guys a couple of nice examples of what a ggplot can do, or other packages based on ggplot. George found these examples, so they're really nice. For example, there is a package called gg word cloud, which takes your text and plots this nice visualization of your text by the frequency of every word. And you can change the shape however you want in this package. So just read the vignette of this package or help section to plot something like this when you analyze a text. Then there is nice dynamic plots that GG Animate can make. So we see that there is scatter plot, which is static for each year. But then when we kind of load information for all of the years, we can look dynamically throughout years how the relationship of life expectancy and any other variable, for example, this GDP per capita, changed in time for all of the countries you want to explore, which is also kind of gives you a lot of understanding of the processes of this data. And one of the last examples, but there are many more, is we can use ggplot in this package ggregis to plot this nice density plots. It's like a smooth histograms by the months, so by some time period for temperature. And then we can add color again, and right away we see that this seasoning. Yeah, so all of these plots are very telling. There are many conclusions that we can get just by visualizing the data in our ggplot package. So now a couple of questions for you guys to try out the ggplot that we just built. The first exercise would be just to change your y and x axis to change your carrot and price. So look at your code.
Yeah. Essentially flipping the plot, right? So swapping the y with the x's, with the x, y with x, swap that. So that's as simple as that.
And don't forget to change the labels. And this is just to emphasize that any setting that you want to get out of your ggplot, you can specify. It could be price by something else. So offline, you can play with those plots to try adding other category variables, other continuous variables. Yes, it is very powerful. And then the next exercise would be to attach a new dataset, MPG dataset, and to draw similar scatter plots by using different mapping. Here's the example of what we want to plot. And we just need to fill in pieces. So again, we're using the scatter plot, ggplot, specifying the data. Now it would be MPG. And to see what type of plot we'll get out of this. And you guys can read about MPG dataset again in help to understand all these variables. And just to think a little bit about when you see the scatter plot, what does the colors and relationship mean for this data? And maybe we'll give a minute, George, for them to go through this exercise.
Yeah. Yeah, and again, you can. Some people have been asking questions. We have been answering them through the chat. And yeah, so go ahead. If you have any questions, you can ask it through the chat. We can answer it. And as Natalia said, so there are a lot of different types of plots that you can build with Gplot. So, and if you go to the help file of Gplot2, you will see how many of those are. So I will bet. I think I'm not exaggerating when I said that, including the if we count the other R packages that are enhanced Gplot2, there are hundreds of different types of plots that you can do. So from including spatial like spatial data, if you have like I don't know, maps and things like that. If you're into social network analysis, you can also plot that. If you're into genomic data analysis, there's also some very specific types of geomes built by other users that enhances ggplot2. So there's a lot of ways that you can use ggplot with. Okay, so someone is asking, Wang is asking, how could I preview the plot in the R console without R Markdown? So I think that one way, so that's an option in general. So yeah, I don't know if you know that. Can you go to the R Markdown file, Natalia? Maybe in the no, but in RStudio. So that because that's an option that you can modify.
So somebody is working with R Markdown, right? So let
me. Yeah, because as Natalia mentioned, the entire presentation was built using R Markdown. So, okay, let me. The thing is that by default, it will show the plots when you run it on R Markdown. It will show them on inline, but you can modify that. So actually, let me share screen a little bit, Natalia.
Yeah.
So I can show that. Let me share screen with you guys so you can see the question. Yeah, so when you have a lot of windows here. So, okay, so these are the slides, right? So this is actually the document that we use to generate the whole slide. So you don't need to use this now. On Thursday, Karen will tell you more about R Markdown, how to work with it. But when Anki was, sorry if I'm mispronouncing it, was asking is that how can we make sure that when we plot this using R Markdown, it's shown in the console and not here? Because if, for example, if I run this by default, it shows us it inline. Some people like that, some may not. Well, the way to change that is that if you go in your RStudio session, let me just make this bigger just in case. If you go here, there's a configuration button. There's like a button. So if you click here, you can essentially, you can ask, what is it? You can tell where to show the outputs from the code. In this case, I have it inline, but if I switch to output to console, it will actually do that. So if I for example, if I do this now, it's not showing here, but actually it's now showing it in the plot area. See? So again, so in order for us not to see it inside of the R Markdown file itself, we can actually go here to configuration and set the preview chunk output in the console instead of inline. And you can modify that in the actual R Markdown file. If you go to the tab, you will see that now I had an extra option here. This is a bit more advanced, but you will see on Thursday, you can specify, like, give a lot of options, how you want this to be rendered and everything. And this is telling the RStudio that I want to see the output not in line, but actually in the console. Does that answer your question? Cool. Okay. Okay, Natalia, you can continue. Maybe we can now see the solutions for the questions.
I think you have to stop sharing your screen so I can.
Okay, go ahead.
Okay, so let's look at the solutions. The first one it was pretty simple exercise, but just to show you guys the flexibility of all the settings, we just changed our X and Y axis. Now everything is flipped, kind of transposed. And also don't forget to change your labels again. So everything is consistent. And the plot pretty much looks the same. Just now we have price on the x-axis and the diamond weight on the y-axis. Okay, and then the other one was a little bit more creative. We had to attach a new data set and specify a mapping. And the titles were in place already for you guys. So we get this nice scatter plot where we have relationship of our engine displacement in liters by the highway miles per mile MPG. And again, we see, so our coloring now factor is drive variable, which means whether it's a four-wheel drive, forward, or rear-wheel drive. And this is our scatter plot. It is interesting to see that our front-wheel drives, they have higher MPG with the lower engine volume, right? And then our four-wheel drives, they have like very low MPG with pretty much the same engine displacement as the rear-wheel cars. So again, some of the inference we can get, some conclusions out of the simple scatter plot colored by a drivetrain. So this is for the exercises, and I just wanted to give you guys example of a box plot just to see that we use geopoint here to plot the relationship of two continuous variable, price and carat. Now we can use box plot to plot the relationship of our continuous variable price and the categoric variable clarity, or cut, or color, anything. So you try it by yourself, but basically that would be the plot that we get. And we'll see there is some trend in price that well, it is weird. It looks weird, but we still can try to explain why this relationship looks like this for price and clarity. So try box plot, try histograms, geopoints. On this data, on the BG data, it would be a really nice exercise for you guys, just to get a sense of what is all the functionality in ggplot, or at least some of it. And then just George wanted to give you guys a very nice references for the online books. For example, I actually learned R using a book and online courses. I never had a class in R. And then, yeah, and I had George, of course, to teach me stuff. And then we have Markdown books, R Studio tutorials, a lot of tutorials for R just in YouTube. They're all free. Yeah, and webinars. And thank you guys for joining us.
Yeah, so thank you. Thank you, Natalia. Very nice presentation. Thank you very much. So yeah, I strongly recommend you guys to taking a look at bookdown.org. I just reposted the link there. I'm going to do it again because so yeah, the same way we build this presentation using just R Markdown. Somebody asked what's Markdown there. There's actually a way to write entire books using R as well. And because of that, there's this website that's called bookdown.org that has a collection, a huge collection, about dozens of theme-specific books about R. So if you're into genetics, into spatial analysis, into causal inference and whatnot, you will be able to find a particular book that teaches you how to use R for that application. There are also some books about like a data science with R. The R for data science book is great. That's by Hadley Wickham, the same author of the Gplot package. And if you are again into high performance computing, you will see some of the resources there. Again, we will share with you some other give you some pointers. I'll send an email around about resources that we have built that we have in-house. And yeah, that's it. And tomorrow, so tomorrow we'll continue with this. Tomorrow will be Eric talking about data wrangling. Another short, like a motivational example exercises using Dplyr, which is part of the Tidyverse. And finally, on Thursday, Karen Zhu will tell us about R Markdown. How can you essentially build your own documents, interactive documents using R, without having to copy and paste the plots and the tables and just do it all at once in a single document, which is great for reporting and papers. We will share the video as soon as it is posted online. So thank you very much. Thank you for attending. Any last questions before we leave? Yeah, so maybe now I can unmute you guys. I think I can unmute you if anyone wants to ask anything. Yeah, I'm not sure how to do this. Yeah, some people are sleeping, but yeah, no. So again, so thank you. Yeah, so unmute. Yeah. Whoever wants to talk, everyone is unmuted now. I don't know if that was the best way, but you can ask a question. So again, thank you for participating. Any question? No. Okay, so I think we're clear. Again, thank you, Natalia, and thank you everyone for coming.
Everyone.
See you tomorrow.
Thank you.
Thanks. See you tomorrow.
Bye.
Thank you.
Hi, George.
Yes.
Just a quick question. Is using Mac is better than using Windows for R?
If it is using Mac, better than Windows?
Yeah.
So I would say, I don't know. I don't use either. I use Ubuntu. But I would say like what the cool kids are doing today is like most people is using Mac. It is very nice. But yeah, I don't know. I honestly don't know if either Mac or Windows are better. It depends on what you do. A lot of times R in Windows is easier because you will see a lot of times packages are pre-compiled by Chrome. So if you want to install a fancy weird package, the binary is already built for Windows. And I don't know if that's the same case for Mac OS. I've seen people sometimes like having problems installing Mac. For example, a lot of our packages depend on this very important ARM package that's called RCPP, which is like that's in a nutshell, it speeds up things. But recently, some Mac users have been having issues because there's some problems in compiling and stuff. So yeah, I honestly don't know. I haven't used Windows in the last, I would say, 8 years at least. I've just been using Ubuntu, which is different for me. It works, but I'm more focused on our package development, so it might be a bit different. But yeah, no, I think either should work because one of the nice things that R has is that a lot of the packages are like pre-compiled and it's kind of like it works out of the box. So it's not like Python, because sometimes like Python you need to install Conda and you need to install pip and I don't know all these I don't know whatever tool people uses in Python. It's kind of like complicated sometimes, like to meet all the dependencies. In R, that's more straightforward. That is, I've seen that it works way easier. So
okay, thank you.
So just use whatever you feel more comfortable with, I would say.
Thank you.
Hi, George. I just have a quick question regarding what else the bootcamp is going to cover. So is it mainly data visualization, or are you also going to be covering things like some of the data reshaping you do with like deployer chains and stuff like that for like some basic analysis?
Yes, we will do that tomorrow. We will be covering data wrangling tomorrow. Eric will be giving you some examples of that. And yeah, and if you want more advanced, I will send some pointers. We do have the materials for last year, and yeah, so yeah, if you have any specific question, if you want me, I can send you guys like more. If you have any specific question, just send me an email, and I can send you like detailed information about like more advanced topics if you want to.
Will we be going into like for loops and stuff like that? So I'm trying to build some loops, but it starts getting a little messy.
Yeah, no, we're not looking at loops
Okay.
Not in these sessions. Last year we did that, so I can share with you the contents of last year, because in last year, like a second track, we have more like a base programming, for loops, while loops, functions, and that kind of stuff.
Got it. Okay.
Thank you. Any other question?
Hi, just a really stupid question.
That's
So,
not
I'm basically like brand new to R, and then like I was going over the question B2 solution, and I see like some of like the codes are like colored in different way. Am I supposed to see that also in when I'm like typing that in? Cause like I'm like basically copy and pasting the question B2 solution, but like not getting any plots. So
oh, okay.
yeah.
So did you get an error? Did you load the package Gplot2?
Yeah, I actually have already installed the ggplot2, but like nope, I don't see any plots. And then like the error that I'm seeing at my console is that error unexpected symbol in, and then like it's a whole bunch of like this space.
Right. So you might, if sometimes it might be the case that you either miss a parentheses, or when you copy and paste the code, maybe you like copy something extra. So that's literally telling you that there's a symbol that R was not expecting. So usually, if you remember, you have the ggplot function that you give the data, and you have a plus sign, and then you have the geom that you're using, and you have a plus sign. So maybe you have something, I don't know, I cannot see your code. So that's one of the problems of having these things online. But it should be essentially that. So if you go online, so let me, if you try to run it directly from the presentation, it should work. Okay. So the template that we have, that shouldn't run. Because we have it, when we set it up the problem, we put like this within we wrote like a data with this, I don't know how you call this, within brackets, data, and then data geom. So that mappings that won't run, because that's just pseudocode. The thing that runs is the thing that is after that.
Okay. Also, like I don't know how to explain this, but like, you know, there's like parentheses, and then like there's like a angled parenthesis. So on like question B, it says I should fill out the missing pieces. So in that angled parenthesis, I just put like whatever I want, right? But without the
angle
quotation mark.
Yes, yeah. So that's the thing. So so again, so that's just a template. That's just pseudocode. So the angle, the whatever. English is not my mother language, so I don't know what's the word for that.
Yeah, I don't know.
That's not supposed to work. So that's just for you to have an idea. But what works is what comes after that.
Okay, cool. Thank you so much.
You're welcome. Okay, any other question? No? Okay, so thank you very much again for coming. Thank you, Natalia, for presenting. We will share materials and the presentations as soon as we have them available. See you all tomorrow. Okay. Cool. Bye.
You guys.